Hey everyone. I wanted to quick go over the idea of criteria and constraints. You've already looked at it quite a bit with the video you just watched about the underwater device to help the fish get to the surface, right? I want to review what it is, just wording it in a little different way that hopefully is helpful, and then you'll go ahead from this video and move on to defining the criteria and constraints for the problem that you've decided to solve. So, criteria, guys, and constraints, one way to look at it is to think of them as being the do's and the don'ts of your project, okay? So, what does your project have to do to be successful? And what should your project not do to be successful? Okay. So, criteria are like the do's. So, for this, you're like, your project needs to do all the following things, right? With the Rapid Blood device, remember, your project had to keep blood within the temperature of 2 to 6 degrees for 20 minutes. It had to fit, if I remember correctly, 300 milliliters of blood, right? Those are all the criteria that it has to fulfill to be successful. The constraints are the don'ts, like the limitations on that, right? So your project can't do the following. So an example of this, guys, would be on the Rapid Blood device, right? You couldn't use a pre-insulated material. It had to be you had to be able to use it in a way that was safe. You had to have there was a financial constraint that your parents put on you, right? How much money would your parents let you spend on this project? Right? Those are constraints, the limitations that limit you. The way I like to think about it, guys, is when you're starting an engineering project, the first thing you do after you've researched the problem, right, is define the problem that you want to solve. And you all should have already done this. The more clearly you define the problem, the easier it is to come up with the criteria and constraints. So, for example, if you define the problem as being, I want to make water better, right? That's like really vague. It's going to be really difficult to figure out a way to how to define the criteria and constraints and then solve that problem, right? But if your problem is, I want to make sure that turtles eat less plastic, that's a problem that's much more specific and it's easier to set criteria and constraints for. So criteria are like, okay, here's our problem right here, right? This is our problem we're coming up with. The criteria is what it needs to be successful. So it's like this big old thing. It has to do this, has to do this, has to do this, has to do that. Anywhere in that, as long as it does that, it's successful. Oh, but wait, then that's where the constraints come in. Oh, but you can't spend $1 million on it. It has to be operated safely. It can't hurt the environment, right? Those are all limitations. So like this represents this constraints circle, represents the limitations that are put on the criteria. So you can't kind of just do whatever, right? So like a very common constraint you're going to see, which I've already mentioned multiple times, is a financial constraint, right? You can't. Rarely are you in a situation where you can solve a problem by spending as much money as you want to. Generally, in order for a solution to be realistic, it has to like not cost a ton of money, right? So keep that in mind as you're designing your criteria and constraints. Just to review, guys, you watched that video of the engineers trying to come up with a device to move the fish from the bottom of the ocean to the top of the ocean, right? And how to help the fish survive despite the temperature change. I want a quick review. You're supposed to write down the criteria and constraints in the video. It was a little bit difficult because I didn't really define them super well, but I want to quick review the criteria and constraints that I saw in that video. The criteria are the do's, right? So what did the device have to do to be successful? Well, the device in the video should be able to go underwater, right? It should keep fish at the same pressure the whole time, so they don't explode, right, or die. It should be small, sturdy, sleek, and light. That's what one of the engineers said at one point in the video. And it should be able to withstand the high pressure in the ocean. So when it's really down far deep in the ocean, it shouldn't be crushed, right? It should be able to withstand that pressure. What couldn't it do, though? Some of these are more implied than stated. The device in the video should not cost very much money, right? It should be made of materials that it should not be made of materials that are difficult to find, right? Like he mentioned that he used materials off the shelf, which means like you can just get it at the store, easy to find. And last one, this was kind of implied. I'm sorry, it should not be harmful to the environment, right? Those are all like constraints or limitations. You can't just like do whatever the heck you want. You have to like figure out how to come with these, how to create a device that follows these criteria, but within these constraints that you come up with, right? Criteria, the do's, and constraints, the don'ts. So right now, guys, what you're going to move on to, you've already defined your problem. So make sure after you watch this video, you write out clearly in this paper what your problem is, right? You've already defined it on the previous assignment you did, so you can just copy and paste it. And then to figure out what is your criteria, like in order to solve this problem, what does your solution have to do? Oh, but wait, what limitations are you working under? Those are the constraints, okay? Hope that's helpful. Reach out if you have questions, but feel free to rewind and watch this video if that's helpful as well. And good luck defining your criteria and constraints.